about the book club. Video camera is optional, but it's encouraged. It's just great to see people's faces. I'm sure many of you have sat in a Zoom call where you jump in and all you're talking to is a bunch of black screens. It's not very engaging, but it is optional. You don't have to have it on, but it's just encouraged. The big one that we as kind of a cohort have kind of established is if we need to slow down and discuss, let us know. Don't be afraid to interrupt the presenter. If you have a question about something, most likely someone else is going to have that same question. And so don't be afraid to say, hey, Collin, I have something to say, or hey, Ryan, I want to jump in and say this. Don't be afraid to do that at any time in this book club. And in fact, I think many people who have done book clubs have noticed that by doing that, you learn a lot by having those discussions rather than someone just reading from a PowerPoint. So definitely feel free to do that. Take the time to learn the theory, understand the why behind what you're doing. Please attempt the chapter exercises. We found it that if you can do the exercises, you're learning a lot from just doing those. And then please plan on teaching one of the lessons if at all possible. And we'll talk a little bit more about the schedule tonight. I don't know if many of you have accessed the GitHub schedule yet. I've linked it in the thread that I posted, I think yesterday. So you should be able to access that. If there's a specific topic that you want to present on, let us know. We'll add you to it. And in fact, we encourage you to do that because teaching the lesson, if you could teach it to somebody, then you learn a lot as well going through that process. So with that, we're going to kind of jump into tonight's discussion. The main focus tonight is talking about Git and GitHub. So we're really just going to do kind of a very broad overview of using this tool. So to kind of get us a little bit started off, can just a show of hands, how many people have used Git or are really familiar with Git? Okay, so 1, 2, 3, little people. Okay, good. So about half of people are really kind of familiar with Git and GitHub. And so if you are kind of familiar with GitHub and you've used GitHub and used Git before, some of the stuff is definitely probably going to be a review. Big thing is that we want to make sure that everyone kind of has a foundation of how to kind of get started with Git, because one thing that we're going to focus on as a book club and as a cohort is we're going to try and actually develop an application together. And so we're going to kind of talk a little bit more about that as the book club progresses, but for us to kind of collaborate and to develop this kind of app that we're kind of considering is that we have to learn how to use Git and we have to learn how to use GitHub. And so we'll have to kind of do a little trial by fire for some people that aren't really familiar. So what we're going to talk about is we're going to talk about Git and GitHub tonight. We're going to kind of talk about some basic workflows when using version control. We're going to talk about, we're going to give kind of a broad overview of some of the common commands that you might use with Git. And then I'm going to kind of demo some workflows using both the graphical user interface in R, and then I'm going to encourage you and see if I can demo doing some of these in the actual terminal itself. So that's kind of the roadmap that we're going to go. I do want to give you a quick disclaimer. I am not a software engineer or developer. I am traditionally trained as an analyst, and I attempt to use Git for version control. So I say that mainly because I will probably get something wrong, especially if you're somebody who is a Git master or uses Git every single day. There's more than likely I'll probably say something wrong. In those cases, please correct me. Definitely, because it's going to teach me, because again, this whole thing is about us learning. And so if I do something wrong, it's okay. I would like to learn. And so, but I just want to tell you that a lot of this stuff is self-taught. I've self-taught myself to do this, and I've learned it from experience by dealing with merge conflicts and all kinds of stuff like that. So, and so I am far from a Git master. So if you're somebody who's like really into Git internals and how it all works, and you know SHA values and how to use those and stuff, this conversation may not be for you. And you know, we'll get to shiny stuff, but we're going to kind of focus on some of the foundational stuff with Git first. Okay. So thinking about the roadmap and the quick disclaimer, does anybody have any questions or comments before we kind of start diving into what Git is and what GitHub is? Okay, great. Awesome. So let's kind of start off here. What you're going to see here is I'm going to jump away from my slides for tonight. What's kind of nice, and we'll talk a little bit about this, but the first cohort has been putting together a pretty much a book down project that has been kind of used as like a study guide. So I've been trying to use this to integrate some of the stuff we'll talk about tonight as we kind of go through this. But if you want to create slides, that's fine. You have access to this information. I can share the link a little bit later in the Slack, so you have access to all this. Currently, this is just my local changes, things that I've added to this book down, and I haven't pushed it up to GitHub yet, which we'll talk about here in a second. But these changes should be going up into the repo pretty much after the group. But let's talk about what Git is. And really, Git is a version control system. Now, some of you might be sitting there saying, okay, that means nothing to me. Well, when you think about what Git is like a tool. It's a tool that is used by developers when they're collaborating on big projects. Now, I put a little asterisk by developers because it's not just developers and software engineers that can use Git. Data scientists and analysts have been adapting to use Git for their needs. And so a lot of the time we're starting to move into, and hopefully your organizations, because you're here using R, are switching into more of a kind of a code-based approach to data analytics. And because you have that kind of code-based approach, you can start leveraging some of these tools that Git and GitHub provides to write better code, to collaborate, and to have better project management. And so really what Git kind of does is it's kind of manages the set of files in a structured way. And how it manages those files is it uses what's called a repository. Now, anytime you hear repository, just think of it as a file folder. That's basically it is. And I mean, I don't want to simplify it too much, but when you think about a repository, it's just like a collection of files. And if you kind of really want like a simpler explanation of this, all Git is as a tool, there's two ways to kind of think of it. First, it takes snapshots, catalogs, and assists in the documentation of any changes to your files. So when you make a change to your files, what Git is doing in the background is it is tracking those changes and provides you tools to document any changes that you're making. The other thing is, if you want an even simpler explanation, is it's pretty much like Microsoft Word's track changes on steroids. That's basically what it is. It's tracking any changes that you make. So how do we actually access Git? Well, hopefully you've had the opportunity to install Git. Did anybody have any troubles installing Git, or is there anybody that still needs to install Git? It's okay if you do. Just raise your hand and just let me know. A couple people, and that's okay. And you may have some issues downloading it, but I'm going to kind of assume that you've already downloaded it. But let's kind of talk about how you can actually access and use Git. So the two most common ways that people access it is through one of two ways. It's either using a graphical user interface, such as a GUI. If you're going to use a GUI outside of rStudio, you're going to have to download it. A good example of a GUI that you can download is the GitHub one. So we'll talk a little bit more about GitHub here in a second. But a good example of this to do track changes and to do version control through a graphical user interface is through the one provided by GitHub. I've also linked a bunch of examples for you of different kind of GUI clients that you can use. There is just a myriad of different types of ones that you can use. There's some that are free, there's some that are paid. But if you're somebody who likes to do point and click with some of this stuff, you can access the GUI, different GUI resources. But again, this is available in rStudio, but if you want one that's external to it, it's available to you. How many people here who are familiar with Git use a GUI when they do version control? Anybody? Nobody? Okay.
Collin, I can jump in on that subject for just a moment.
Sure.
So similar to your GitHub service that you just showed on your screen, I actually do Atom Atom is a GitHub text editor. There's extensions to map R as a kernel to run code. It's a long story, but it has a really good GUI interface as well if anybody is looking for a client. I've also used Tortoise SVN, Tortoise Git, but that particular platform, what I would be cautious for any user experiencing Git for the first time, I would recommend some form of a GUI if you're unfamiliar with your folder structure. As you gain experience and confidence in using Git, it's more powerful from a command line interface. And so using those commands, I know you're going to cover that subject here in a moment, but use the GUI first, or even within rStudio, and then branch off and actually start using the command line directly. And that's like even more powerful than that.
Yeah, thanks for jumping in. Yeah, I mean, to be honest, I've been using version control probably since 3 or 4 years for my own workflow. And I started in a GUI. Like, I had no idea what a git add, git pull, git push, what all those commands were. So I was like, you know what, I'm just going to use a GUI and see what happens. And if you are starting out with Git, just use a GUI. And again, we'll talk about it in rStudio, so you don't have to download one. But know that there are a ton available to you, some free, some paid. And yeah, definitely use them. Use whatever tool that you want to use. So with that, so we have some examples, and then we also have some that are built into rStudio for ourselves. And so I'm going to pull up my R instance here in a second, but there is a specific tab near your environment that's called Git. And so I'm going to pull mine in here real quick. And my structure might be a little bit different than yours, but it is a window pane. It's closely related to, it's close to your environment tab. For some of you and how you have it set up, your environment may be in the top right, but rStudio does have a Git tab in it, and it provides a user interface that if you just want to do the point and click, you're more than welcome to do that. So definitely use that. If you are not seeing your Git tab, you may have to change your settings. Please come talk to me about it, and we can kind of figure it out to get that set up if you don't have that available. So what's also nice about this is that you can also use your own terminal to do Git commands. And we'll talk more a little bit about kind of the basic workflow and some of the Git commands that you might use. But a lot of people, what they find out is they transition from using a GUI into using a terminal and actually writing out the commands. For those who are familiar with Git, how many of you have used your terminal, or how many of you do strictly use terminal to use Git? 1, 2. Yeah, I am straight terminal from now on. Like I have to use the terminal. I am a Mac user. How many Mac users do I have? Cool. How many Windows users do I have? I'll be 100% honest. I know how to access the terminal for my Mac. For people that are interested in or using Windows, you may have to use a different type of tool. I think PowerShell is the one that's used for Windows, but correct me if I'm wrong. Windows users jump in. But the other thing that's nice about rStudio is it has an integrated terminal tab that you can access your terminal. So if you are on Windows, you can access your terminal via your actual rStudio instance. So if you're somebody who's on Windows and doesn't want to integrate anything, and you don't want to use PowerShell or something like that, you can use the actual terminal to access and write in commands. So does anybody want to add anything about the Windows, any terminals that people use, or anybody want to add to that? Because I am unfamiliar with how to use that in Windows.
Yeah, Windows has an app, an app store called Windows Terminal, and it's pretty awesome, and allows you to use like terminal commands. And you can also have like a, I don't know, like dual boot Linux on top of Windows as well, which makes it easier. I can link instructions in the Zoom chat or in the Slack chat for reference.
So, and to kind of move on from this, you know, if the system terminal is something completely new to you, just stick with a GUI. Just stick with a GUI and then use that. and then see if you can start learning some of the commands to transition to actually using a terminal. But here's kind of my example of how I kind of do my workflow. I do everything in the Mac terminal. When I say terminal, it's just basically a place where you can enter commands. It's kind of like your console on rStudio. So if I pull in my rStudio again and I have my console, right here is basically what I'm doing in the terminal, but I'm just talking to my computer rather than I'm talking to, R. So if anybody's interested, I don't know if anybody uses zShell. I love zShell. I think it is an awesome addition to your terminal. I don't know how I would work without zShell, but some of the stuff, if you're kind of familiar with the terminal and you see some different kind of like pieces to it, it's a great addition to it. I don't know how many people are using it, but if you are going to be somebody who's going to be focusing on the terminal and want some extra tools added to your terminal, zShell is just awesome. I highly recommend it. It gives you ability to kind of change your command line, to add different things to it, which we'll talk about as we get to each one of these pieces, but you can kind of modify it for your workflow. And I think it's just awesome. So let's talk a little bit about, so we talked about rStudio terminal. So again, if you're somebody who doesn't want to use your own system terminal, you can use the terminal in rStudio. So you have access to a terminal via there as well. If you do have any issues with that, you may have to change your settings, or you may have to start up a new terminal to actually use it. Okay, cool. So that is Git. Let's talk a little bit about GitHub. GitHub basically is just a hosting service for your projects. So Jenny Bryan and the Stat 554 TAs and Jim Hester and their Happy Git and GitHub, GitHub for the useR basically define it as this. Think of it as a Dropbox, but much, much better. It's basically a cloud-based service where you can store all of your projects and all of your file information. And so a lot of stuff is hosted on GitHub. Another thing that I kind of think of GitHub is it's kind of it's a collaboration, project management, and I loosely say this, but it's kind of a social media platform as well, because you can communicate with other people across your projects. And it provides many tools to improve your work and to work on different projects, open source projects, private projects, whatever it may be. So if you haven't done already, make sure that you do get a GitHub account. Here is my GitHub account. Basically, it's a place for you to manage all of your projects. Again, just think of it like Dropbox for all of your code. If anybody wants to follow me, my follower list is a little low. I'm only at 5. So if you want to follow me, go ahead, please do. How many of you are familiar with GitHub and already have a GitHub account? Okay, a few of you. If you haven't yet, you're going to want to, because most of us are going to collaborate via this. I'm definitely going to get some more followers because you're going to be collaborating with me. But basically, just think of it as like it's just a Dropbox to hold all of your stuff. Okay, so we have this one. We were talking about repositories a little bit earlier. Basically, this is the repository, and I actually have this fork. This is the fork repository for our book club ourselves. And you can actually look up this and access this. But basically, our book club for all of these materials that we have tonight are going to be up on GitHub for you to access through this repo on GitHub. Again, it's just like a file folder up in the cloud. That's all it basically is. So you can kind of look through these materials. Again, this repo contains some review materials that the first cohort put together, but it's something that we can use as well to kind of collaborate and kind of share our materials as well. But what's nice about this is I've already updated the README file to contain our schedule and kind of projected out what kind of topics are available. So the README is just basically a file that we're using to, it's just basically a text file to which, GitHub renders so you can actually see it online. But basically you can read this information, kind of see where the schedule is inside of this repo. But what's nice about this is I pulled this file down, made changes on my computer, did some Git commands and pushed it up, to which then you can access pull down, make changes, and push back up. Now that's a very, very simplified version of that workflow, but that's just basically what you can kind of do with GitHub. It's just that hosting service to hold all of your code.
Collin, quick question. So if you go back to where you just were, the GitHub.
Sure.
So if you scroll up, there was on the side, it has 14 contributors. I recognize some of them from Slack. So is it safe to say that like that might have been the original cohort that put the content in there first, and then now you've come along, you're in the contributors as well, and the rest of us will be. And so so it's all just these are the same files as the first cohort was using, and now we're just joining in on it.
Basically, yeah. So and there's some more concepts that we'll have to talk about. We'll talk about pull requests. We're not going to get to those today, but we'll talk about branches and pull requests. But basically, it's a way to kind of create a version that you can push up into the repo that somebody can review before they integrate it into the actual file structure. Again, I don't want to get too far along because, you know, we're talking about the foundations of Git tonight, but there's going to be some more advanced topics that we'll discuss about how we branch and do those versions. Did that answer your question, Ryan?
Yep, thanks.
Okay, cool. There's other services out there, Bitbucket, GitLab. I really don't use them. So if you ask me a question about them, I'm not going to know much about them, but I would probably understand that they're the same foundations. You know, if they're using Git in the background, it's probably the same foundations, and you could probably get up and running if you understand Git. Does anybody use Bitbucket or GitLab here?
Collin, I'm going to jump in real quick if you don't
Sure.
mind. Yes, I'm a heavy GitLab user. Just as a comment, I'm usually a very anti-proprietary person. I'm more of a Linux user. So Microsoft acquired GitHub in 2019. So immediately I took all of my projects and forked them over to GitLab instead. So just as a common comment, I have nothing negative towards Microsoft. If you choose to go that route, I'll support anybody that does. I frequent GitLab more often than not. So I have both accounts. I'm not as active on GitHub. So.
Yeah, and that's okay. Like, yeah, if for those that were kind of following it, the big kind of acquisition was GitHub got purchased by Microsoft. We could have the debate, you know, back and forth which one you want to use. I've just used GitHub, and that's the one that I've always used, and so I really haven't thought too much about using GitLab or not. But if somebody has GitLab questions, you know, pass them along, because again, it's a service that's available to you. At least for GitHub, I know you don't have to pay for the free version, but if there's some things that you want access to, you have to pay for the pro version. I'm working really hard in this book club to make sure that you don't have to pay for anything. So if you paid for something or you've been asked to pay for something for GitHub, you shouldn't have to. Okay. So, but if you're interested, it's only $4 a month if you want the pro version. But okay, cool. So let's talk a little bit about kind of a basic workflow. Again, we're going to talk about the very, very basic kind of steps that you'd kind of take to actually do a Git workflow to kind of pull stuff down, to push things up, and to kind of document any change that you've made. So one thing that I do want to highlight is that this is going to be completely foundational. But if you're somebody who wants to kind of get some of the more advanced steps or some of the more advanced things regarding Git, there's a great book called Pro Git. If you haven't read this yet, most likely if you search anything Git related on Google, this is probably going to be in your first couple hits for sure. This gets in depth. It's kind of, you can treat it like documentation, but if you have any questions that are not answered by some of these foundational things, this is the place where you can find a lot of answers. I do have to say it is very verbose. There is a lot of information in there. So if you want to, you could go chapter, section by section and read it, but there are some places that it gets pretty heavy. So, and there's some stuff that you may not need, but if you're kind of somebody that wants to dig in a little bit more, this is the place you kind of want to look. So let's talk a little bit kind of a step-by-step kind of process of what a workflow looks like. And I'm going to kind of demo this a little bit later, doing it through the GUI and then the actual terminal itself. But you can kind of think of these as kind of like common steps and approaches that you're going to take when you're kind of doing just a basic workflow. And the basic workflow that you're going to kind of do is you're going to pull files down from a repo. You're going to view some information about those files. You're going to make your changes. Then you're going to document those changes, stage them, and then push them. And that's kind of the basic flow that you need to know. Now, for some of you, that may be really overwhelming, and I understand. It's one of those things where you have to kind of do it a couple 100,000 times to really get it. And so if this is kind of going over your head, that's fine. It's just something that you got to kind of struggle with to kind of learn how to use it. At least that was my own experience. If someone got it right away, you're a legend, because it took me about a good 6 months to a year to really understand how to use it. So what you really need to know is all you're really going to do is you're going to pull, make some changes to your files, add those files, make a commit, and then do a push. If you can kind of remember those basic steps, I'm going to pull information, I'm going to make my changes, I'm going to add those changes, make a commit to document them and push them. You have the basic workflow down. Now, there's a little bit more steps to it, and I can kind of show it to you here a little bit when we kind of actually use the graphic user interface. Because anytime that you see the GUI, you're going to see these things. You're going to see pretty much buttons that correspond to these specific steps. Pull, you make your own changes, add, commit, push. So if I go and I pull in our graphic user interface for R, you're going to see these things: commit, pull, push. So you kind of know that these, because they're built into the GUI, these are kind of the basic commands that you're going to need to kind of know. But pretty much any graphical user interface that you have, they're going to have kind of those basic things. GitHub has git fetch origin, which is kind of like pull. You have your commit, so on and so forth. Okay. So this is what it's going to kind of look like visualized. And for the people that have used the terminal or are interested in using the terminal, I provided some kind of basic commands. Now there's many different flavors. There's many different options to these different commands. But if you kind of understand these commands, you're doing pretty good with Git. So anytime that we want to pull a repo down from GitHub, so again, we want to take those files and pull them down onto our computer. If we don't have a copy of them, we're going to have to do a git clone. Okay. You're going to have to do a git clone to pull them down. Now, there's multiple ways to do that in R, and I'll kind of demo those here in a second, but you can just enter the command as well in your terminal if you want to do a git clone. So once you have those files locally, anytime that there's changes that are made to those files up in the cloud, you're going to need to do a git pull. Now, a git pull is just going to pull down those recent changes locally onto your computer. Once you have that information, there's some stuff that you can do to kind of get some basic information about what's happening on your computer. There's git branch, git status, and git diff. Git branch is one of those where it just shows you which branch you're working on. For some of you, that probably went over your head. It's okay, understandable. We'll talk about branches because that's a little bit more of an advanced topic. But the ones that you kind of want to know when you first get started is the git status and the git diff. Git status is going to tell you what files have been changed since the last time you made a commit or pushed it up to a repo. Git diff allows you to see all of the changes within a specific file. Okay. So say you get that information, you make some changes to your files. What you're going to do is you're going to do what's called a stage and document. So when you do this staging and document, what you're basically going to do is you're going to add your changes. You're going to stage your changes. You're going to commit those changes, add some documentation on, hey, these are the changes that I've made. And then you're going to write that short message, save that commit, and then you're going to do the git push. Okay. And the git push is just going to push it back up into the cloud, into the repository. So that's kind of like the basic steps, kind of looking at it linearly, or not linearly, but kind of looking at it kind of step by step and what it's going to look like. And this is a process and a pattern that you're going to kind of constantly do over and over and over again. So this basic workflow, you're going to kind of get into just kind of the same patterns. You're going to pull information down. You're going to view some information about it. You're going to add any changes you had, do a commit, add a message, and then do a git push. For those of you who are familiar with Git, you've done this thousands of times. So this isn't anything new for some people, but talk to anybody that's used Git for a significant amount of time and you'd be like, yep, this is a pattern that I do constantly. So here's a kind of another view of it. I'm not going to go by it step by step anymore, but you can kind of see it kind of visually of what each one of these steps do. You know, you got to git clone, git pull it down to your computer. You can get some basic information about, you know, where you are branch wise, what kind of changes you've made. And then you also have some stuff that you can do for your actual, to track your actual changes. So doing the git add, the git commit, and then back to the git push. So I know I kind of went over that really, really quickly, but does anybody have any questions or comments? Did I miss anything? Let me know.
So with this, you're not actually changing anything in the cloud or in the repository itself. It's always pull everything, or is it pull just what you need down and then change it and push it all back?
That's a good question. Does anybody want to answer? Anybody who's a little bit more familiar?
I can take that on if you'd like, Collin.
Yeah, go ahead.
So Ryan, what we're doing on a git clone is obviously making a mirror image on your local machine. When you modify that local code, you want to push that change back up to the cloud, push it back up to the repository. The Git mechanism or the storage mechanism is only saving your particular commit for others to also download again. And that's why you want to do a pull command if you're collaborating as a team, like Collin had mentioned, the Git Status, right? If you have an older version of that file that you haven't pulled down or localized yet, you make a change to it, you may run into a merge conflict. And I know, Collin, you haven't got to that comment yet. That may be a little too advanced for the team. But to answer Ryan's question, you're pulling down from the cloud, making your local copy a mirror image. You'll never really lose any of the source, which is the cloud-based, the actual Git repository, the GitHub repo. That will never will never break because it's the source itself. Everybody else collaboratively is using local copies of it. It's why the importance of pulling down any updates before actually making changes is important. Does that help, Collin?
Oh, I think that's perfect, Ryan. I'm thinking that you're going to be the expert on this. So
I'm good with that.
I appreciate your comments. So Ryan, did that answer your question?
Well, sort of. So why wasn't Git designed to just manage merge conflicts, everything in the cloud? Like, why does it all have to be brought down first? And then similar to that, does everything have to be brought down? If I'm just going to change one line on one document, do I have to bring everything down and then send it all back?
So we'll start with the history of Git as a service. Git was developed by Linus Torvalds, the same person that developed the Linux kernel. The idea was that he needed a large team of collaboration. When you're looking at the Linux kernel as the development platform, you're talking hundreds of thousands of people. And then that rolls up to some key developers that allow a toll gate process of accepting that change into the actual repo itself, building and compiling the next kernel. So with that thought process in mind, it's kind of almost giving anybody the ability of a touch point. So when you're pulling down the copy or cloning the copy, we'll say, you're making that first initial instantiation of the file format. I go in and start modifying it with my own R program, maybe break some stuff. That's normal. It's okay. The version control component of Git allows a person to roll back should there be a problem with the wrong direction. Again, Collin hasn't got into the branching mechanism. I'm sorry, Collin, if I went too far for you. But the beauty of using Git as a language, whether it be GitHub, GitLab, Bitbucket, or any other storage mechanism, the Git language is complementary to any of those services. So the idea would be that under no circumstance should you ever worry about breaking anything. It's perfectly normal to do that because you just overwrite it again.
Gotcha. Okay. And then as far as pulling everything down, you always have to pull everything?
Actually, when you clone, that's the real large footprint of data flow. When you start to only like fetch the changes, that's just telling you what's different in your local copy versus what the cloud has. Or if you're doing that pull request, you're only really pulling down the changes that were made from some other user. Okay. So let's say that if Collin were to commit to his book down document that he's working on, he commits a change, and then you, Ryan, want to fetch those changes. It's going to show you what has been modified. You can look at the diffs between your file versus the service, the repo side. Then you can pull those down, and it will overwrite or it doesn't overwrite anything. That's the thing that is difficult to explain how Git works. You're not really replacing the file. You're just replacing what's different about the file.
Makes sense. So, okay.
Yeah, it's a very optimized service.
But the first step is to clone the whole thing onto my local machine. Okay. So then let me just think. So let's say that that a long lost coworker that I hardly ever talk to says he wants me to take a look at what he's working on. So I go to that, I download the whole entire thing, make one little change, and then I never need it again. I assume there's a way to like close it out, so I don't have to deal with it anymore.
You could actually delete it. Like if you're working on, like, let's just say this R4DS cohort type process, say you're running out of room on your hard drive. Well, I don't need that repo anymore, right? You can hit the delete key, get rid of that user space, because you could always go back and mirror it again or clone it again.
Okay.
Yeah.
So it actually does write all of the information to your local machine.
Well, it does. Yes, you are taking up hard drive space. Yeah, you would have memory of that particular repo.
Okay.
Once the cohort is over and you say you want to get rid of all that media, you just hit the delete key, and you could always go download it at a later point in time if needed.
Cool.
Good comment.
Yeah. And that's a good difference between, you know, GitHub and Git locally on your computer is that it's storing all of that source code. And like that's where GitHub comes from. So, and that's where kind of
Collin.
Yeah, go ahead.
Another point. I sort of had the same concern when I started using Git, and one of the main things that helped me was that Git is mainly only used for code that can be opened in a text editor. So it's all very small, relatively. Like almost no one commits large files. And in fact, I've really messed up my own repo by trying to upload like a 50 meg CSV. Like, so it's not general practice to commit large files. So you're really only pulling down or cloning a couple megs of data in typical use cases.
So don't store my Avengers movie there.
If you manage to, that would be a first.
Good info. Thank you.
So and just kind of reiterate for anybody that isn't totally familiar with Git, I mean there's a lot to Git, and so if you are feeling overwhelmed, it's okay. Like we'll cover some of those topics, and I'm already going to nominate Ryan to be the person that's going to talk about branching and everything when we get there. So
I'll be happy to, sir.
Yeah, you get the nomination for that. So we're kind of coming up on the 5-minute mark. I've kind of already gone over the workflow commands. I could kind of quickly demo the GUI real quick if people want the GUI. Let's just do it real quick, and then we'll kind of wrap up from there. And then I can demo the terminal commands once people kind of play around with it. Again, the big thing that we want to make sure that we do is that we keep 7 o'clock, because I know other people have commitments after this, and I don't want anybody to feel left out from the cohort if they have to leave. So let's just look at the rStudio GUI here again. Again, I have a project. It's the book club mshiny. I've made some changes. I've built this in I built this within the Bookdown project. You don't really need to know too much about Bookdown, but basically I made changes to it. And so what's happening is that Git on my computer is basically saying, hey, you have all of these changes that you've made to these specific files. So what I can do is I can actually track these changes, and what I'm going to do is I'm just going to stage them or commit them. And so the first step that I'm going to do, if I wanted to, I could pull the information down if I wanted to. So again, I'm pulling it from GitHub to kind of update it. There are no changes that are there, so it's already up to date. Okay, so I don't need to worry about that. So let's just say I have these changes, I made them, I want to commit them. So I'll just click on commit. rStudio kind of has this sub menu that provides you a description of the changes that you've made. So you can see here are all the files that I've changed. And then down here, it's going to show you what are some of the things that you've changed. Some files, depending on what they are, you may have information. A lot of these are pictures of the diagrams that I have, so I'm not going to have any information here. But I've made some changes to this file for tonight that I want to track. So what I'm going to do is I'm going to first kind of add them. I'm going to stage them, and it's going to be an add. And then what I'm going to do is I just want to add a basic commit message. Now we can talk about the different things of what you should add in a commit message, but what you want to do is you want to kind of give a description on what you're changing. Now, this may be specific to your specific project, but I'm just going to kind of keep it short and sweet and say added new content. Again, you can add as much information as you want, but the best thing is make sure that you make it descriptive. So once you do this, you can just do the commit. Now, I just stored this commit locally on my computer. I have not pushed it up into GitHub just yet. So for me to actually push it, I need to click the push button. And all the push does is it takes it and pushes it up to GitHub. Now, we haven't really talked about forked repos. We could talk about that a little bit later or next time. But basically right now, if I went to my repository on GitHub, those changes will now be there. And just so that you know that I'm not lying to you, I'm going to go over to GitHub and show you. Or for DS, I got to go to my forked one. Forked. You'll see that I've now added that chapter here, and I changed it about 39 seconds ago. So again, I committed it, added a commit message. I pushed it up into the repository, added new content with this commit right here. So that's kind of using the GUI. We're kind of at the 2-minute mark, so I can kind of talk about how to do this in the terminal next time. But that's basically how you can kind of use those basic commands using the GUI. So does anybody want to add anything?
I think the only thing left is really to make sure we have something for next week. So is there more? I guess there's more here, Collin, that you wanted to cover for next week.
Yeah, basically it would just be demoing it in the terminal. Well, here's a question. Let's ask us, how many people would like to get the demo in the terminal? Raise your hand. Okay, so Connor. So there's a couple. It won't take me very long. So maybe about 15 minutes to kind of go over some of the commands that you would need in the terminal. So the schedule that I have up basically says that we're going to just start digging into chapter 1 next week.
Okay.
So
what about a demo in the GUI? Is anybody interested in that? I could just watch YouTube videos.
And if people need, if people want if people want to stay after, I can stay a couple minutes after to kind of work it over, or we can sit down and go over it again too at a later time for somebody that wants more practice with it.
I think it would be good to jump in on chapter 1 for next week, since it is, after all, the mastering Shiny cohort. So maybe we can get into that, and then if anybody is willing to be available for like tutorials or other questions, maybe we can connect up just in the Slack and set up time that way. Does that work? So so I would say if you're available and you can be a resource to help people if they have questions about this, then just make yourself known in the Slack, and then you can connect and start working that way. And other than that, we'll jump into chapter 1 next week. And who's gonna? Oh, is that you, Collin? You're gonna handle that?
I have it listed unless somebody else wants to jump on it. I just took responsibility because we're kind of leading the group, but that's up to anybody else.
You go. Why don't you handle it, and then we'll be able to assign some other people out for future weeks too. Cool.
Yeah, and if anybody wants to go through this list and sees a topic that they want to take on, please let us know.
Yeah.
You can jump in tonight if you wanted to say that you want to take on a specific topic. Cool.
We can leave it there. Thank you, everybody, for joining, and I invite you, please come back next week and continue on the rest of the discussion. Other than that, we will talk to you in the Slack.
Thanks for hosting. I really appreciate it.
Yeah, no problem. And if anybody wants to stay after and kind of discuss a little bit more, you're welcome to do that. But I don't want to hold anybody if other people have other obligations. So
sounds good. Thanks, everyone.
Thanks, Collin and Ryan. See you.
Okay.
Thanks. Bye.
Bye. Collin.